In this class, we're going to look at how we can look at raw data and divide them according to certain class intervals to look at frequency distribution. So we already understand what frequency distributions are. We understand how we can take scores and understand them using frequencies, especially in terms especially in cases where we have a lot of scores that we need to analyze. So frequencies would kind of tell us which score is repeated the maximum number of times, right? So in cases where we have large number of data, when we have the sample size as something greater, then we would use class intervals to kind of simplify the data. So not just use each category of scores inside the data set, but categorize them according to class intervals, which would suit us as people who are doing the research and proceed with our calculation. Let's consider this for an example. Let's consider a data set where the uh, minimum score that's present in the data set is 51 and the maximum score that's present in the data set. So minimum score is 51 and the maximum score is 96. Now how do we create class intervals for this? So the class intervals would look something like this, right? So 50 to 54. So 51 would be somewhere there. So the bottom class interval, the most bottom class interval would contain the minimum score that you have in the data set, and the maximum score would be in the last class interval on the other side, right? So 50 to 54, 55 to 59, 60 to 64, 65 to 69, all the way up to 90 to 94. Now, how do you decide the width of the class interval? So in this case, the width of the class interval is 5, right? Meaning for in each class interval, the amount of values that can be inside it is what we refer to as width. So in this case, the class interval's width is 5. Now we have four guidelines to kind of decide how we would go about creating these class intervals for grouping data in a table. So let's go over the first guideline. The group frequency distribution table should have about 10 class intervals. Notice how it says about, which means it doesn't have to be equal to 10 class intervals. It should be around it because we like numbers that are, easy for us to interpret. You understand that you probably know numbers that are divisible by 2, 3, 5, 10 better than numbers that are divisible by say 7 or maybe 8 or maybe even 9, right? Because we like numbers that are kind of simple and useful for our everyday application. So when you look at multiplications of 2 or multiplications of 3, multiplications of 5, 10, they're much more easier for us to kind of interpret and much more easier for us to kind of make sense out of compared to the other values, right? So it is good if we could kind of use class intervals, the number of class intervals that could, the number of class intervals, if we could have around 10, that would be like a good rule of thumb to follow. Um, The second guideline would be something to do with the width itself. Again, the width of each interval should be relatively a simple number. This is what we discussed last time as well. So last time we were looking at the total number of class intervals. Now we're looking at the width in specific, right? For example, 2, 5, 10, 20 would be a good choice for class interval width. So class interval, the total number approximately 10, because if it goes beyond that, the table looks too huge. And for the width, it's always nice to have a number that's divisible by 2, 5, 10 or 20 because it's easier for us to kind of process that information. Now, when we look at the third guideline, right, the bottom score in each interval should be a multiple of the width. If you are choosing a width of 10 points, for example, the interval should start with 10, 20, 30 and 40 and so on. So if we can kind of again use the number that is convenient for us to use and have the same value at the bottom. So if we're looking at the width of 10, have intervals that start with 10 so that it's easier for us to process information. Uh, the last guideline, all intervals should be of the same width. So this is something that we already know. This is also something that we saw in the previous table. So if the class intervals, let's say we have 10 class intervals, if the first class interval, the one that's at the bottom, it has let's say a width of 5, the next class interval should also have a width of 5. You cannot have the width of 5 for the bottom one and then 4 for another and then 3 for another, especially when we're looking at the same table. So if you decide on a particular width value, then we stick to that for the entire table, right? So they should cover the range of scores completely with no gaps and no overlap, so that any particular score belongs in exactly one interval. Now, let's kind of look at an example to understand things a little better. So let's look at a data set that we have here. So here, the sample we have is 25. So again, when you look at the raw data this way, it looks a little too much. Now let's simplify it. So first thing to look for when we're looking at creating a table, a grouped frequency distribution table, is to understand which is the lowest score and which is the highest score. So in this particular data set, you have the lowest score as 53 and the highest score as 94. I hope you're able to identify where 53 is and where 94 is. So that's how we got the two values. Now, when you're looking at the creation of the table itself, we need to decide the width, right? So if we decide on the width of 2 as the width, right, you will have 21 different class intervals. If you decide on the width of 5, you have 9. If you decide on the width of 10, you have 5 as the total number of class intervals. Now, if you remember the guideline number 1, right, we saw how it's always advisable to have the total number of class intervals to be equal or around close to 10, right? So in this particular example, the width of 5 is close to 10. You have the width, the class intervals coming up to a total of 9. So you'll end up with 9 different class intervals if you use the width 5. So I guess that's what we're gonna go with, right? So in this case, because we have 9 class intervals, this is how it's gonna look, right? So if you look at the raw data, and you can kind of look at the values that will fall between 50 and 54 and write the frequency for that. You can look at the values that fall between 55 and 59 and write the values for that. So in this case, we're looking at any number that falls between these two values and we count the frequencies, right? So this is kind of how it's going to work. We're looking at the real limits here. We're not looking at, so in this case, if 54 is something that you get, 54 would be something that belongs to the first class interval. If you're getting 55, then it would belong to the next class interval. I hope it's making sense so far. Okay, so let's do a learning check for this one. So for each of the following situation, determine what interval width is most appropriate for a group frequency distribution and identify apparent limits of the bottom interval. So let's say the first scores range from x equals 7 to x equals 21. So the answer would be you have to first calculate the width and see how many class interval you would get. So for the first one, the most ideal would be using 2 points for the width, which would give you 8 class intervals. So the bottom interval would be 6 to 7. For the second one, x equals 52 and the maximum score x equals to 98. You can again work out the table and see what would work out. So I have the answers here. Just check if you are able to get the same answers on your end as well. So I'm just gonna move to the next slide now, but you can check and see if you're getting the same thing. The second learning check, using only the frequency distribution table below, how many individuals had a score of x equals 74. So this is a group table, right? Grouped table with class intervals. So 73 would fall between 70 and 74. So this is the class interval we're interested in. And the question is asking us how many individuals had a score of 73. Obviously, we know that 73 is something that falls in this criteria We have the frequency number, but we don't really know how many 73s are present, right? But we know there is a chance that all the three scores that are there could be 73. But we cannot say for sure. It's a, it's kind of a guess that we are taking, because there are three in this category. All three could be 73, or none of them could be 73, because we're looking at a class interval. So here the answer would be to kind of admit that we will not be able to determine that, because this is a group frequency table. That's about it. I hope you understood how to group data. Remember, statistics is something that is used to simplify data for our processing. We are not just, playing with numbers, just for the sake of it. We are trying to understand data and what they could mean. So to simplify it, we group them in class intervals that would again be easy for the human brain to process. So with that, I'll end this lesson.